Hello everyone, so today we'll be solving couple of problems from electrostatics field and force. These problems have appeared in JEE exams. So the first problem is charges Q, 2, Q, 4, Q are uniformly distributed in three dielectric solid sphere 1, 2, 3 of radii r by 2 r and 2 r respectively. If the magnitudes of electric field at point P at a distance r from the center of spheres 1, 2, 3 are E1, E2 and E3 respectively, then four options are there and we have to choose the correct options. So first option is E1 greater than E2 greater than E3 and so on. Okay, so let us first find the electric field because of the sphere 1 and so let us start the problem. So let us find E1. This is the electric field because of sphere 1. Now sphere 1 has a radius r by 2 and it has a charge Q uniformly distributed throughout the sphere, and we have to find field at this point. This point is outside the sphere. We have to remember over here, if there is a spherically symmetric charge distribution and if we have to find the field outside the distribution, then that the field at that point would be simply the field because of the total charge. We assume that total charge is to be concentrated at the center and find the field. So what I'm saying is this: if we want to find the electric field at the point outside the sphere, okay, then all the charges that is distributed throughout the sphere could be considered accumulated at, at the center of sphere. So we can find out the electric field as if there is a charge Q situated at the center of sphere instead of considering the whole distribution. So at the end, what we have to find? We have to find the electric field at r, at a distance r because of the point charge Q. Okay, so electric field at a distance r because of point charge. So it is a straightforward formula, 1 upon 4 pi epsilon naught. We are assuming that these spheres are in vacuum. Q, the point charge at the center, divided by the distance r square. Okay, so this is for the sphere 1. Let us move to sphere 2. Sphere 2 also has a point on the peripheral of the sphere 2. So the same principle that we have applied for sphere 1 will be applied for sphere 2, because if we can consider that total charge distributed throughout the sphere is concentrated at the center as a point charge with a charge magnitude as 2q. Okay, so E2 will be also easy to find out, 1 upon 4 pi epsilon naught 2q upon the distance is again r square. Sorry for that. Now we have to find E3. E3 is a bit complicated than previous two cases because the point P is inside the sphere at a distance r from the center and the sphere has a radius of 2r. Okay, now we have to remember the field at point P will be only because of the distribution that is shown over here. So this outside distribution of the charge means over here, whatever the distribution of charge is, won't affect the electric field at this point P. The electric field at point P will be only because of the charge distributed inside the sphere, imaginary sphere, through point P having the center, okay, and having the same center. Okay, so what is our task? Next task to find out is how much total charge is distributed in this smaller sphere. If we could find out the total charge, Then similar in case of sphere too. This case also will be treated similarly. We will consider that total charge as to be concentrated at the center. So our only task is to find out the total charge because of this smaller sphere. Okay, so smaller one, we have to consider the smaller one only. Okay, so first find out this total charge for it. So total charge in smaller sphere, distributed in smaller sphere, and here the case we are considering for sphere 3. Now we know 4q charge is distributed throughout the sphere volume having the radius 2r. So what information we already have, that 4q charge is distributed throughout the volume of the sphere with radius 2r. What is the volume of sphere with radius 2r? 4 by 3 pi 2r cube, which is nothing but 4 by 3 pi 8r cube. So let me write down 8 over here, 8r cube. We can see this 4 by 3 pi r cube. So volume of this bigger sphere is 8 times the volume of the smaller sphere, because the smaller sphere has a radius r. So the volume of smaller sphere will be what? So I will write down over here what will be the volume of smaller sphere. So volume of smaller sphere through point P is 4 by 3 pi r cube, because it has a radius r. Okay, and this volume of sphere with radius 2r is 8 times the volume of smaller sphere. Okay, so 4q charge distributed in the sphere of volume 8 times the volume of smaller sphere. Okay, 4q charge distributed on a sphere with 8 times the volume of smaller sphere. So how much charge will be distributed in a smaller sphere? Of course, if 4q is distributed 8 times the volume of smaller sphere, the charge distributed on or throughout the smaller sphere will be 1 upon 8 times total charge. Okay, because 4q 8 times Vs, then 1 upon 8 times 4q will be q by 2. So q by 2 charge is distributed throughout the smaller sphere. Okay, so once we know q by 2, we can consider a point charge q by 2 is centered at the center of the sphere, and at a distance r, its field will be what? Now it is a straightforward thing. So E3 will be what? 1 upon 4 pi epsilon naught q by 2 upon r square. Now we have to see who is bigger, E1, E2 or E3. So E1 is this, E2 is this. So we over here we can see E2 is 2 times E1. So we can see E2 is 2 times E1, and E3 is 1 upon 2 times E1. Okay, E3 is half of the E1. So E3 is smaller than E1. Okay, E3 is smaller than E1. But E2 is 2 times E1. So E2 is larger than E1. So this is the answer. What was it? E3, E2 greater than E1 greater than E3. E2 greater than E1 greater than E3. So option C is correct for this problem. Okay, let us move to a next problem on electric force, electrostatic force. Okay, the problem is as follows. Two charges each equal to q are kept at a distance x equal to minus a and x equal to a on the x-axis. Okay, so let us first draw the xy axis. So this is the x-axis and this is the y-axis. And also the charge is at x equal to minus a and x equal to plus a. So I will have to draw the axis on the negative side also. So if this is minus a, let me just uh, move it further away. So if this is minus a and 1 2 3 4 1 2 3 4, this is a. Okay, so the two charges are placed at these 2 points. The charge is equal to q. Okay, this is equal to q, and a particle of mass m and charge q naught equal to q by 2, half the charge of these particles, is placed at the origin. Okay, so there is another charge placed at the origin, which is equal to q by 2. If the charge q naught, which is equal to q by 2, is given a small displacement y, where y is very much less than a, along the y-axis, the net force acting on the particle is. Okay, we will consider the displacement that is given uh, to this charge is in this direction, in y direction, y plus direction. Okay, so let us say this is the small displacement. Sorry, let us draw this again. Okay, so let us consider this is the small displacement y. So, and all this and this charge is of course q by 2, and these we are considering the charge of the same sign, either all are plus or all are positive or all are negative. Okay, all three of them. So if they are of same sign, there will be repulsion between any of the two charges. So because of this charge at minus a and charge at in the y direction, there will be repulsive force like this. Okay, the vector will be like this. Similarly, because of this other charge, the vector will be like this. Okay, now let us draw the components of these vectors. The first component will be in the x direction, second in y direction. Similarly, for this one component in this direction, minus 6, and other will be this. Of course, both these forces are equal since this distance is also equal and charges are also equal. So the horizontal components will cancel out each other. Okay, so we don't need this component, so I will just erase it. And the vertical components will be 2 times one of the vertical components. First, let us calculate what are the components of these two forces. So if this is F, if this force is F, then we know F cos theta, and this angle is theta. Let us draw this again. This was F cos theta and this was also F cos theta in the negative direction. So let us say minus F cos theta, and both got cancelled. Okay, and now what we left with F sin theta. So if this is theta, so we have here 2F sin theta. Okay, if this is theta, we know if this angle is theta, this angle will be theta. Okay, this distance is y, which is very minuscule. So and this distance is A. This is Y. So we can easily calculate what is tan theta. Tan theta is Y by A. For small theta, if theta is small, we know tan theta is nearly equal to sin theta, which is equal to theta, and which is Y by A. For small theta. Okay. Now let us come back to this force. The total force on this charge is 2F sin theta, where F is a force because of individual charge, individual force between these two. So the total force is 2F sin theta. Please note that we don't have to carry each and every term which is constant, since we only need to calculate the proportionality, that force is proportional to what. Okay. Okay, so this is it. And yes, we have to calculate whether force is proportional to y minus y, 1 upon y, or 1 upon minus y. Okay, for the solving purpose, I will keep all the constant and all the terms in this formulation. Okay, so total force is 2F sin theta. The single force is 2. What is F? 1 upon 4 pi epsilon naught. The force we are calculating between these two charges. So this is Q and this is Q by 2. So Q into Q by 2 will be Q square by 2, and whole divided by this distance square. Now we know by Pythagoras this distance is y square plus a square. So square of that, so root will vanish and we will have this into sine theta. Okay, we know sine theta we have already calculated as y by a. Another thing we can say, we know a is very much larger than y. So a square plus y square will be essentially nothing but a square. So let us again write it, 2 into 1 upon 4 pi epsilon naught q square by 2. Just let us erase this. Q square by 2, 1 upon a square into y by a. Okay, we know all these things are constant, and so we know the total force. Let us denote it by curly f, is proportional to y only. Okay, so this is the answer. If uh, if if this one of the charges would have been opposite to these two charges, then we would know that the total force would be in this direction. Okay, and this total force will reverse as soon as this particle crosses this origin. The force would be in this direction. So the particle will, this with charge q by 2, will perform an oscillatory motion if had it been a oppositely charged as compared to these two charges. Okay, so in that case it would have been oscillatory motion. But in this case, what is happening is that this charge is going in y direction, and total force is in y direction, so charge will keep on moving in that direction. Also please note that as this y will increase, the total force will be proportional to y. Plus, but please note that this result is only true for a very much greater than y. Otherwise, other factors will also come into picture. So these are a couple of problems we solved in electrostatic force and electrostatic field. We'll see you in next video. Thank you for watching this video.